to talk to you. Thank you, Wale, once again. And I hope it will not be too late to wish you a happy World Day for Safety and Health 2023. April 28th is the day set aside by the International Labour Organization to mark the World Day for Safety and Health. Various professional bodies have been doing that. NICT has done its part. On Friday with the National Symposium and Safety Awareness Works in our various chapters. And we also joined the IOSH network to carry out a session as well yesterday in Port Harcourt, that's River State, in Lagos, and also in Abuja. So in line with the World Day for Safety and Health, we have the theme, a safe and healthy working environment, a fundamental principle and right of workers. Yes, indeed it is. Let's look at the construction industry. The media, various media, social media, mainstream media has been awash with incidents of building collapse. And of course, when a building collapses, you are bound to hear the loss of lives, not just the assets, but lives. And that is one or two persons that we may know or not who have perished in the course of daily breath searching. The construction site is one of the work environment that has the highest rates of losses. No fewer than 61 building collapse across the states of Nigeria have been recorded in 2022. And in 2023, we have recorded multiple cases in just 4 months. Case in point is the banana building collapse recently, and another one recently, just last week in Apapa. These collapses occurred despite various efforts being put together to rid the country of building collapse. According to the report by the Building Collapse Prevention Guild, out of these disasters that have happened, out of these failures, structural failures, Lagos State recorded 20 of the incidents, representing about 48.7% of the entire cases in Nigeria in 2022. So, ladies and gentlemen on the bridge, in this presentation, we shall look at stages of construction. We shall also look at building collapse, look at the role of engineering, look at quackery in the profession. So my topic is building collapse and quackery in the engineering profession. I also like to say that quackery is not only in the engineering profession, it's in all professions. We will see that as we proceed in the course of this presentation. So typically, let's start with the build-up to know what construction is all about, to getting to a point that the building construction actually fails. The construction is typically divided into 4 phases. We have the planning phase, the pre-construction phase, and the construction phase, and the closeout phase. If we look at it in the project management perspective, we have 5 phases. We have the project initiation, which is also termed as planning. We have the project planning, which is the pre-construction phase. We have the project execution, which is the construction phase, and we have the project monitoring and control phase, and the project closeout phase. We start with planning phase, which is the first phase for any major process that we want to carry out as regards construction. In layman terms, we say the planning phase is when the owner consults an architect, consults an engineer, gets a construction manager, and they have the early discussion on what they intend to build. To consider that what they will intend to build, will it be approved by the regulatory authorities, the state and federal? At the planning stage, this is where the early retention of professional comes in. Planning a construction work requires details, requires retention of professionals. On the planning construction side, we have not just the architects, we have the architects, we have the engineers, we have the builders, all of these professionals and the project manager bringing their ideas together based on what is being conceptualized. So in this phase, the project architect will work closely with the civil engineer to determine the setbacks for property lines. We'll check the easements, slopes, check the steeps, the lots, and all the preliminary activities prior to starting the design. All this will take time. So if it is not understood and these procedures and processes are not followed, people will often try to rush this planning phase, and they just leap into the design and the creation of drawings and construction documents in order to go ahead to start the bidding process and the construction project. So therefore, in this case, a construction manager is required, where he will gather complete professional team, he will retain the general contractor, he will develop a project budget and overall schedule, carry out the risk management aspect of the job, contract and insurance and other project organizational businesses required for that job. And all this will be done in planning. So basically, planning represents a small percentage of the overall cost of the project, but planning has immense impact in the construction phase. Just like typically at home, you say if you fail to plan, you're actually planning to fail. So early planning steps also include site and building assessments. We also have the early engineering evaluation and entitlements, the land use analysis to determine if the owner can be allowed to build. You know, the town planning, for instance, there are some areas which are designated for commercial areas, some for industrial, and some for residential. Even in the residential areas, there are some aspects where you cannot build maybe a high-rise, for instance, because the government has designated certain categories of buildings to be built in that section. So all this has to be looked into by the construction manager, the architect, and the engineers at the planning phase. From the planning phase, we move on to the pre-construction phase, where the architect commences with a construction document, which they translate from the early planning exercise into the contract documents. And from there, they will proceed to submit it to the building approval authorities for permits. So basically, the architects call this the three phases: thematic design, design development, and construction document. That's the pre-construction phase. We move on to the construction phase itself, which is actually the execution phase, where you have professional teams at sites. You have the construction manager, you have the architect, you have the engineers, you have the builders, you have the safety engineers on the site. All these should be engaged for a full construction administration on site. While doing this, they will perform quality control inspections. There are times where organizations may come in, regulatory bodies may come in and request for information for review and approval. So these technical documents will be at the site, even after having submitted it to the regulatory authorities. This is to ensure that the project is delivered by the contractor as designed. So construction basically depends on a team. It is a team approach. Because if you have a professional team and the professional team diligently and properly executes the planning and pre-construction phases, then the construction will progress smoothly. Key aspect is the construction manager. The construction manager here services the site. He will carry out on-site project management. He will check the quality control, monitor the contractor's safety program, ensure contractors perform per specifications, coordinate permits, technical inspection, testing and monitoring the request for information and submittals that have been sent to ensure that they are all on track. But in the industry, most times you see people start erecting structures without having somebody to really, a professional to oversee the construction. And that's where we're driving at when we're going to talk about the Quackery aspect of the job. So we looked at the planning, we look at the pre-construction, And we look at the construction phase, which is execution, and we now move on to the closeout phase. The closeout is actually the final phase of the project, where the client gets all the project information, the diagrams, the schematics, the approvals. At the end of the day, he has a construction closeout document list. He goes through the checklist to check line item by item to ensure that it has been closed out properly. And all the closeout documents, including manuals, warranties, as-built designs, and also the accounting process, checking how much has been spent on the project, checking timelines being followed. Insurance also must be changed from the cost of construction, because when you are in the construction phase, there's a level of insurance that covers it. After that, after the whole construction phase, the insurance actually changes to directly to be that of the client. We also have commissioning. This is basically for larger projects like high-rise buildings. So commissioning is basically a formalized process which is utilized where systems are tested to ensure their functionality. All right. If it's a complicated system, those facility will be tested. The owner of the facility will be shown how to operate it. Let's say, for instance, a high-rise building is erected, and coupled with the building, you have the fire alarm system, addressable fire alarm system. The facility owners will be taught on how to operate the system and other aspects of the facility. So that comes in the commissioning phase of the job. This is very critical, because if proper closeout is not done, if not given proper attention, that good project that was conceptualized and executed can become a problem for the owner. So the project closeout procedures include more than just the completion of the project, or more than just turning over the project to the client so they can transition to occupancy or operation. You need to show the client how the facility can be used. The client needs to understand the blueprint and the functionality of that facility during the closeout phase. Now, we'll be hearing the news, building collapse, and people wonder what is going on. Is it that these buildings were not approved? Is it that the engineers, of course, people basically always blame the engineers, that the engineers were not on site or did not know what to do? A lot of concerns are there. I tell you, most of the buildings that collapse do not have registered engineers on them. Even at times when you have the engineers and the work is not done as per design, as per specification, the engineers pulled out from those facilities and the crash happens later on. Also, the regulatory authority, the government, may have done a prohibition notice, may have put a seal to stop, giving a stop work order, but people still go back and continue the building. Most times at night, most times, of course, they put a barrier around, a fence around, and they continue the building. So let's look at regulatory approvals. How do we build? What are the steps in building? What are the steps in getting the approvals to actually build? So we know that the government actually has regulatory oversight, and the government is doing its part, though more is expected. So we're going to look at the regulatory approvals, right? So we are here in Nigeria. I would like to use Lagos as a case study, not that Lagos is the only place that buildings have been collapsing. Okay, we have reports of building collapse in Abuja, in Akwa Ibom, in Uyo, in Imo, but Lagos has been in the news recently a whole lot. So let's look at the regulatory framework governing the grant of building permits. with Lagos State as a key example. So please, Lagosians, pardon me for for using Lagos as an example. Okay, so let's first note that building control regulations within Nigeria are within the control of states and local governments. So they vary from state to state. So you may not say the same set of rules in one state in another. All right. So let's use Lagos State as an example. Now, the grant of building permits in Lagos State is governed specifically by the Lagos State Physical Planning Permit Regulations 2019. And the enforcement comes through a number of regulatory agencies. They include the Lagos State Physical Planning Permit Authority, which is under the Ministry of Physical Planning and Urban Development. We also have the Lagos State Lands Bureau, we have the Ministry of Environment, and we have the Lagos State Building Control Agency. All right, so if you want to erect a building, high-rise building and the likes in Lagos, these are the agencies that one will have to work with and get approvals from to handle this. So let's start from the most important requirements for one to make a valid application for a building permit. You must have the following requirements. Of course, a photograph of the building construction site. The government needs to know where you want to build. They want to see the layout of the land. They want to see the location of the land and what are the existing structures near where you want to build. All right, a passport photograph of the applicant should be presented also. Okay, and if it's a company, for instance, you want to see your CAC, or Certificate of Incorporation from the Corporate Affairs, a certified true copy of the title document proving the ownership of the land on which the construction project is to take place. You can also have a title document, allocation letter, a certificate of occupancy, or registered conveyance where applicable. Or you can even get a clearance letter from the Lands Bureau where the title document is still being in the processing phase, or from the Land Use Allocation Department. So how long does it take? What is the validity of these building permits? Basically, building permits have a total validity period of 2 years, within which a building plan and application must commence construction. So you have your building plan, within that 2 years, you have your building plan and have the approval, you're expected to commence construction. So what's the duration? What duration does it take from the time of requesting for the approval to when you actually get it? It's basically a minimum of about 60 days. About 60 days. About 60 days, the approval is out. And Lagos is very speedy as regards this. At the Center of Excellence, they are always setting the pace. All right. So still looking at that, after you apply for that, you must also provide a survey plan of the land you're going to build on. Present your tax clearance certificate or evidence of your personal income tax payment. If it's a company, all right, or a company coming to build a high-rise or any other such facility, or a real estate company, the applicant will have to provide tax clearance certificate for at least 2 of the directors. Then pay the assessment fee, tenements. Hello, team on the bridge. Can you see me?
Yeah, we can hear you now, sir, but the slides, We can't see the slides, sir.
Okay.
Yeah, I think the network. Okay, yes, you are live now, sir. Thank you, sir.
Okay. So please, where did you drop off, please? I think here. This is where we were, right?
Sir, yes, sir. Just 2 seconds
Yes,
back.
sir.
Yes.
Yes, sir.
Yes. So one of the key or major reasons of building collapse is the lack of soil tests. Before I got knocked off, I was saying that no two topographies are the same. None in this country. The same setting, the setting of soil you have in Ogun, in a Ota, in a Wekoro, it might not be the same as you have in Agbara. Not at all. The setting of soils you may have in Akure might not be the same you have in Umunede. Not at all. Talk less of Lagos. Talk less of an area that is an island, an area that has swamps. All right. We recall that some areas in Lagos are sandfield. All right. You have the Magodo and all those other areas. So requires a soil test for any building project to know the type of soil and to know the type of piling, the type of construction you are going to carry out. Also required is a fire safety clearance from the Lagos State Fire Service. Then a confirmation letter may also be required by the Newtown Development Authority. A signed letter of structural stability and integrity report by the Council for the Regulation of Engineering in Nigeria, accredited professional, especially where the project is a building renovation. So COREN regulates engineering in Nigeria. And for construction activities, the services of a civil engineer is required. Not just any civil engineer, a specific civil engineer, specific to the work. Yes, Tim, we're going to discuss that as we move on further in the presentation. So an architect will be required to bring forward an architectural plan, which should be duly stamped by a member of the Architects Regulatory Council of Nigeria, ACON, a structural drawing duly signed along with supervision letter from a current accredited engineer affirming good construction standards. And that current registered engineer in this context that will bring about the structural drawing, sign it, stamp it, and seal it is a structural engineer. A structural engineer. An architect can design, but for the building to stand, a structural engineer must calculate the structural aspects and sign off on it. The question for us is, as professionals, what is your signature worth to you? What is your signature worth to you as a professional? Because most times, people may just sign off on any document without actually understanding what they're signing off. Structural drawings, structural calculations are not to be done by any other than a licensed civil engineer who is a structural engineer. And of course, registered by Council for the Regulation of Engineering in Nigeria and the Nigeria Institution of Structural Engineers, NI-STRUC-E. So you must have that current accredited professional who will stamp the calculation sheet for the materials to be used for the construction project. We also couple with an environmental impact assessment report from the Ministry of Environment where applicable. So again, what is your signature worth to you as a professional? This is where we need to stamp out Quackery in the engineering field and other fields as well. We'll look at this as we progress. So do we have any other fees that we may be required to pay up while sourcing for the permit approvals? Well, perhaps you could be required to pay for the following: a building plan approval, application fee, a layout fee, a fencing fee, a certificate of fitness levy, a registration fee. Okay. What if you are actually carrying out a renovation of a building, maybe probably a bungalow? You may not be required to do all this. So basically, you bring a survey plan, architectural plans, structural drawing, and a supervision letter from a current registered engineer who approves that the renovation can actually be done, and your task clearance certificate. So you now submit it to the regulatory authority, and your looking at a summary of building permits and approval. To start your building plan for your permit, you will need your land title documents, like we mentioned, COO, certificate of occupancy, your survey plan, title deeds, your architectural drawings, which is done by a registered architect registered by the Architects Registration Council of Nigeria, your structural drawings by none other than a civil engineer with a structural competency, a civil engineer specific to structural engineering, a member of Nigerian Institution of Structural Engineers and current registered, of course. Then the physical inspection will be carried out at the construction site. So basically what you need in that aspect is to get your lawyer to procure your land title documents, to commence the title registration application immediately, as well as getting your task clearance certificate and payment receipts. You can also get your regulatory fee, get the architect to do the drawing, get your structural drawing from a structural engineer with detailed calculations along with the statement of structural stability. That document must be signed, sealed, and stamped. Then you wait for your physical inspection of your construction site by officials of the Ministry of Physical Planning and Urban Development. The host, please, we have more people joining. Please do the host and allow the E, please. So you commence your application for a main building permit. Within 5 days, you get your grant by the Lagos State Building Control Agency. Please, it must be noted that while the project is going on, your site may be visited by any of the regulatory authorities, and there will be a request for information. And saying that you do not have it with you, the approvals or the permit with you at the time, is not an excuse. You are expected to have all those building approval documents, copies of it at the site. So team on the bridge will be talking basically about building collapse. We're starting first with the process of getting building approvals and the phases of building construction. We look at the planning phase, we look at the pre-construction phase, we look at the execution phase and the closing phase. So now we've moved on to talk about the steps in getting a building approval. All right. This is just to buttress the point that when buildings fail, it doesn't mean that those buildings were just built by individuals without going to the regulatory authorities for approval. Most times approval is given for 4 floors based on the structural calculation. Some other person goes to put 1 or 2 extra floors there, which is not in alignment with the construction documents. So we've had a summary of the permit approval phase. Let's look at what building collapse actually is. Building collapse is a sudden structural failing, which could be partial or entirely of a building. And with this comes the threat to human life and health. When you have an internal load-bearing structural elements failing, a building will collapse into itself, and the exterior walls may be pulled into the falling structure. In the picture that we have pictures of building collapse. Key for me is the one to your left, which happened in Uyo, 10 December 2016. The Rena's building collapse, where multiple fatalities were recorded. If you're just looking at the picture, you could see you could see the cave in there at the center, where the beams all fell, and the loss of life was great. A lot of lessons have been learned from this incident. We hope that with regulatory authorities and all as individuals will have the political will and presence of mind to ensure that we follow the best construction practices to avoid unnecessary loss of life. So we look at structural failures as regarding building collapse. So the structural failure can cause a floor to fall horizontally onto the floor below. So once one floor falls on the other one, the added weight may cause that floor and subsequent floors to fail based on the weight and fall to a lower level. But not at all times does it go to the ground level. Let's look at the types of structural failure. Looking at the types of structural failure for construction elements, we have the compressive, the tensile, the bending, and the buckling. So what are the signs of structural damage to a house? You can have cracks in plaster, brickwork, and stonework. This can just be superficial, but they may also be telltale signs of a more serious issue, a more serious settlement issue. I use Lagos again as a case study. For areas that are sand fields, for areas that are marshes, for areas that are swamps. I recall years ago at Ajegunle. Yes, at Ajegunle, I observed a particular building was settling. Gradually, the building was settling and people were still living in it. And at a point, it buckled in the corridor. I and some other engineers that passed by, we assessed it. And we told the occupants of the building that this building is coming down. Some already started making plans to leave. The building already began buckling. And when we say buckling, what do we mean? Let's look at this, for instance. You see this. You see my notation. Please confirm you can see my notation, please. Hello? Okay, we're all muted. Okay. So the building buckled.
Yes.
And after a rainy night, the whole building collapsed. It was raining heavily. People woke up in the morning to say that the building had collapsed with a few persons inside. So construction of buildings, we need to consider also the location and the soil type. That's why it's key that soil tests must be carried out. So those cracks you observe in the brickworks, they can just be superficial, but they may also be sign for more serious settlement issues. You can have the building settling on one side more than the other. You may have sticking windows and doors. You may have bulging or leaning walls, sagging roofs and roof leaks, and uneven floors as well. So what causes these structural failures? They have poor communication. Yes, like I said, the job is not done alone. No major construction site can be supervised by just one person. It says an architect designs it and it ends there. No. Design may look beautiful on paper, but the workability, or rather should I say the sustainability of that facility depends on the structural elements, and that is handled by the structural engineer. So most of these building collapse are all basically stemming from structural failure. So you could have poor communication between the various design professionals who are involved in the project, like the engineers involved in the conceptual design, the architects, and those involved in the supervision of execution works. The design has been done. Architectural design, the structural.
Hello, I think we. Hello, sir, are you there, sir?
Yeah, we can't hear him.
I think the network. I think it's currently offshore, so I think the network there is having issues with the network. But I think it will be back very soon. Please kindly exercise patience where we are waiting. Very soon, we will be through very soon because we have other, like I said from the beginning, we have other programs that will be starting by 6 o'clock also. Please let us exercise patience while we wait for him to complete this session. Thank you.
I'm back. Thanks to our wonderful network.
All right, sir. You're welcome, sir. Okay. Thank you, sir.
Thank you for welcoming me. All right, so we may have poor communication between the fabricators and the erectors. We may also have defective designs. Okay, defective designs that have not determined the actual loading conditions on the structural elements. And another thing, inferior construction materials may also be the cause, since the loads are calculated for materials of specific characteristics. What is the cement you are using? What is the mixture? What is the quality of iron rods and sizes? And also there's a failure of soil testing. So basically, in Nigeria, the most common causes of building collapse have been traced to bad designs. And of course, that stems from quacks, faulty construction, use of low quality material, which could be unintentional or could be intentional, hasty construction, rushing to meet deadlines, foundation failure, lack of proper supervision on the site. Then you have the regulatory authorities not carrying out their functions as required, where you have ineffective enforcement of building codes by the relevant town planning authorities. Then we also have lack of proper maintenance and a silent aspect, corruption. ladies and gentlemen on the bridge. So these are basically the common causes of structural failures. So we have some types of structural failures. It can happen in one or two different forms. It could be a complete failure. It could be a partial failure, which could be remedied. Okay, when we have complete collapse, the entirety of the structure falls down. With the partial collapse, only a part of the structure falls. Only a part of it fails, and before it falls, it can actually be remedied. So whether we have partial or complete, most of these failures can be categorized as follows. You can have a V-shaped collapse. That's if the floor joints become overloaded. The center of the floor may collapse while the walls remain standing. So everything collapses to the center. You may have a lean-to collapse where the wall collapses and based on the load-bearing capacities of the walls, which are not in line with the expectations. So what happens? A part of it collapses while the other part remains standing. You can also have the A-frame collapse, which collapses in the form of a tent. The floor comes loose from the exterior walls, but the center interior remains intact. So it falls to the side and the center remains intact. So it falls like a tent. We also have the pancake collapse where the different floors fall on each other. And you also have the cantilever collapse, where the central support that holds one end of a structural element extends outward. So that cantilever may collapse and leaving the one or more structural walls failing. And at the end of the day, all the reinforcements remain on one side of the wall, thus causing the full collapse of the building. So a collapse may happen immediately or it may happen slowly over time, it may be progressive. So one of the most common concerns or most serious concerns with any structural failure is the potential for it to be progressive. So we say basically a progressive collapse occurs when the failure of one or more primary structural components causes the other elements of the structure to fail. So one falls on the other, creating more load on it. So this is very dangerous. Progressive collapse could occur if the remaining walls or walls are not properly reinforced. Yet again, when we talk about reinforcement, what's the quality of materials we're using? What's the quality of our concrete? What's the quality of our rods that we use? What is the ratio? How do we mix it? So understanding the mechanics of the building collapse is essential, very, very essential for us to determine the causes of structural failures. Knowing the materials we use in terms of aggregate, in terms of rods, knowing the type of failure that occurs in terms of structural failure could also give us a guide to identify where we had potential lapses, where we could identify if there was a potential negligence on the part of the contractors, as engineers and the architects and the others on site, and subcontractors, or the owner of the property, or we want to know if it's based on the material manufacturer and other parties, so we can know where the blame lies. Because you could do all the best engineering analysis, do your diagrams, do your structural calculations, you go to the market, what is being procured and supplied at site may very well be different. They may very well be different from the expectation. So how do we prevent building collapse? First, you need to hire an architect, register with the Architect Registration Council of Nigeria, hire a structural engineer, please. And that must be current registered engineer and NI/E registered, specific to structural engineering. Because we have different aspects of engineering, different aspects of civil engineering, which we're going to treat later on. You need to carry out a soil test to prevent building collapse. Use suitable foundation design and construction. Hire a competent building contractor, project manager. Follow the consultant specification as building owners, facility owners. Yes, you may want to cut cost, but at what cost are you cutting that cost? What is the foregone alternative? Comply with statutory building regulations. There are codes and standards for every project. Professional ethics should be followed by all professionals at the site. This will help in preventing building collapse. When a building collapses, what is the consequence? Loss of life, property, and huge sum of capital, like the last collapse that happened in 21 stories building. Even the owner of the facility, loss of life, properties, and huge sum of capital for those that bought into the property. Loss of reputation and integrity, which can also lead to psychological trauma, mental health problems, which could even lead to suicide. Loss of new commissions, contracts being revoked, agreements being cancelled. Loss of revenue follows. And for the engineers, withdrawal of practicing license by the regulatory authorities. Example, COREN, Council for the Regulation of Engineering in Nigeria, Association of the Architects Registration Council of Nigeria, then Council of Registered Builders of Nigeria, COBON. Licenses may be withdrawn in that regard. So most of the issues we'll be having are based on high-rise buildings, So we're going to just briefly look at the construction stages of a high-rise development. I know I don't have much time. We have the stage 1, soil testing for the available site, the architectural designs, building permits and approvals, which we've mentioned already. Soil testing is also very important. For us as engineers, soil testing is also known as geotechnical investigation. And there's a division of the Nigerian Set of Engineers, which is the geotechnical, handles the geotechnical aspect. So geotechnical investigation is required. That's soil testing, which is used to learn about the properties of the ground and the soil conditions at the available site. Like I said, no two sites are the same. On the basis of the characteristics of the soil, the bearing capacity of the structure will be estimated, which ensures the stabilization and strength in the longer run. So from the geotechnical engineers, it passes on to the civil structural engineers. So once the soil testing phase is completed, the next thing to do is the creation of architectural designs and the structural features, which plays a very significant role in the development of a high-rise building. So the structural engineer carries this out and then present this design to the concerned regulatory authority. Then after getting the approval, construction can commence. First, they proceed to the site, clear the site, then pour a strong foundation, and they carry out the construction of the grade structure. Okay, so from the approval phase, all the unwanted rubble, debris is being removed from the site. Obstacles are being removed, place cleared. As they're clearing the place, excavation for the site is being done at the same time simultaneously. At this point, you need your safety engineers on site to look at the simultaneous operation, safe or work processes. So for the high-rise building, the construction starts with a deep foundation. And these boundaries are supported by installation of piles, again, based on your geotechnical reports. So once the excavation is completed, the piles are then replaced by retaining walls. So this foundation actually is what keeps the building. Most times building failures, construction failures, the collapse actually starts from the foundation due to poor foundation. So once the foundation of the high-rise building is successfully poured, we now have the basic framework beginning, which is a combination of structural members like columns, we have beams, we have slabs of different materials, such as steel, reinforced cement concrete, etc. When we talk about steel, what's the quality of the steel we have, the rods? What's the quality of cement? We have the Standard Organization of Nigeria, which has oversight on standards of materials which we use in country. But if I was to ask a question now, the rods you probably had, maybe you had any leftovers from the construction project. The rods you had that were, we call it, some people may call it Y12 or say 12 mm rod and 16 mm rod. Are they the same today? If we take a caliper to measure the 12 mm rod, you may see that that gauge is not 12, it may actually be 10. If you take your caliper for 16 mm rod, you might see that that gauge may not be 16, it may just be 14, it may just be 12. So we need to know, because based on your structural calculation, you may say this member may require this gauge of rod and this quantity. But then, in practice, you might find out that what is being supplied at the site is not the same. And these rods are used to produce the columns and the beams, and the columns at the end of the day cannot carry the load. But it has been designed for a specific purpose. So we need to also check the material that is being supplied to us. So most building collapse also stem from the construction materials being supplied. So if you have leftovers from your previous sites, check it to see, are the rods the same? I tell you, definitely not. We also consider the cement used in construction. Is it any cement that we use? Basically, we use ordinary Portland cement, and we also have the Portland Pozzolana cement, which is being used for home construction, for foundation, columns, beams, and slabs. We have three main classes of cement. We have the 3.325, 4.2.5, and 5.2.5, followed by an R rating or an N rating. So basically, the R rating refers to rapid or early strength development. So you do a mix, you want it to set early to get dry early. And the N is to normal or standard strength development. So the rating of 2.5 is the low strength, 42.5 the middle strength, and 52.5 the higher strength. Cement is very important. Of course, we know the role of cement in the terms of application. Okay, so knowing the quality of cement helps determine the strength of a structure. It's very, very important. Like the 2.5, for instance, is suitable for the manufacture of mortars and reinforced concrete works. It can be used for building of homes, factories, hospitals, schools, and different construction needs. So as end users, we need to know what we're actually using for the work and how long do we give it to set. Is it 7 days? Is it 28 days? Korean has a guidance for this as well. That's for the construction personnel. So for the high rise, we go to the stage 7, which is installation of mechanical, electrical, and plumbing requirements and the completion of the exteriors. So after the form work, you now have the mechanical, electrical, plumbing aspects, which includes firefighting systems that are being installed in the facility. You have the HVAC plant, that's HVAC basically heating, ventilation, and air conditioning. Because for some high-rise buildings, you won't have the air conditioning units being standalone. All right, they may be infused with the heating, ventilation, and cooling systems, and professionals for that are being brought in to do the distribution. You also have electrical substation and wires and sanitary pipes being put in. Then at the A stage, which is completion of the interiors, you basically put your fixtures, your windows, doors, countertop, closet, cabinet. You have your escalators, if required, then your lighting fixtures and elevators. All that form the completion of the interior for a high-rise building. So that gives us the overview of the steps it takes to put up a high-rise building. But now for us, what is engineering? Most times, anybody you see wearing coverall in the street, they call them engineer, which is a very wrong perception. Or somebody that stays at the chemist and dispenses medication, they call him doctor. That's the beginning of quackery in whatever profession that aligns with. So what is engineering? Engineering is the creative application of scientific principles to design or develop structures, machines, apparatus, or manufacturing processes or works, utilizing them singly or in combination, or to construct or operate the same with full cognizance.
Yeah, so I think we lost him again. That should probably be because of network. I'm sure he will be back soon.
Yes,
I'm sure he will be back soon.
I dropped off. Thank you very much.
Hello, sir. Engineer Kong, please, we have our time fast spent already because of the other event that is happening on this same account. So maybe
okay, I'm going to
have a part 2 of this session. Hopefully, we have a part 2 of this.
I'm going to run off soon, please. Just give me a few minutes, please.
Yes, sir.
Sorry.
Right, sir.
Yeah, so for engineering, we have civil, structural, mechanical, electrical, and all that. But let's note that for when you say civil engineers, civil is divided into structural engineering, water resources and hydraulics. We have geotechnical, we have environment, we have transportation, we have highway. So not just any civil engineer will do structural. It has to be a structural engineer. So what is quackery? A quack here is anyone who dishonestly claims that he or she has acquired the required training and knowledge in a particular field, but has no competence, certification, or license to prove that. That is the quack. And the actions of these quacks can result in unpalatable consequences. So when you have quacks leading projects that are beyond their training and experience and comprehension, there's always a high chance of project failure in engineering and construction. These failures could be unpalatable and could result in the loss of lives and properties. So to engage somebody to carry out activity, you need to find out what is his competency, what is his antecedents, who has he worked for before. Find out his background. Because the effect of quackery are very wide. It causes hazard to the users. Quackery directly violates one of the golden tenets of design procedures within engineering and allied professions, which is the safety of the user. It decreases the profession, brings a bad name to the profession, because the professionals are more visible to the public eye. So when something happens, they blame the engineer professional on the site. Meanwhile, it is a quack that has been assigned that activity, somebody that is not competent, somebody that is not a member of CORIN, for instance, and NSC. And the quacks also competes with the licensed professional, taking the jobs of the licensed professional. Perhaps they bring jobs at a very low rate. This leads to national economic losses. Professionals are nation builders, but the activities of quacks, on the other hand, are ills to only nations. So therefore, as engineers, as professionals, as enlightened people, please speak up against quackery. Anybody you have to assign any job, find out who he is, what are his qualifications, challenge the person to prove himself or herself. We should guard against quackery, because Quackery does not help the nation at any time. So protect your reputation as an engineer, as an architect, as a builder. Fight off Quackery to ensure you secure your finances. And engineers are always encouraged to abide by the new public procurement regulations. Thank you very much.
Thank you so much, sir. Thank you, my powerful engineer. I believe that we'll still have a part 2 to this, because this is not a session that can be done once. And I know you are always ready for us at all times. Please, thank you all for joining. Thank you all for listening. It's a wonderful section. You know, it happens once in a while like this when we have to have other sections to hold simultaneously. And due to the time factor, we had to rush our powerful speaker because I know he has a lot of things to tell us. He has a lot of things to educate us on. And I hope that we'll always be ready to join at every point in time. Next week is another wonderful moment. We hope to see you once again. We hope to have you. We might not have the question and answer section, but the slides will go around. I believe you're ready to share his slides with us. So once we get the slide, we'll share it on our groups. And if you have any questions about this wonderful topic, you can always get in touch. You can also get in touch with him. If you want to get in touch with him personally, you can chat me up. I would send you his LinkedIn profile, LinkedIn account, so that you can connect with him directly. Thank you once again. Thank you all. We hope to see you once again next week. Thank you and God bless you.
Thank you very much.